Okay, so today we are going to learn about transformations of functions. Specifically, we're going to go ahead and look at absolute value functions. Which I introduced to you in the last video. So basic transformations. So here we have the transformations in function notation. Remember that function notation is f of x. And remember that f of x is equal to y. Okay, so here we can see some variables. Here we have the f and the of the x, but we have these other variables here that represent a transformation. These variables here, a, b, h, and k, are known as parameters. A, b, h, and k are parameters. They control aspects of the absolute value function and its graph. So let's talk about what they do. So first of all, the a value on the front that we're multiplying, that is going to determine whether or not we have a vertical stretch or compression. And since it's vertical, it's going to affect y. Okay? Anything inside the grouping symbol is going to be horizontal. So the b value, which is going to be multiplied times x, the b value is going to be horizontal, stretch, or compression. And the h value is going to be, again, horizontal, because it's affecting the x. Anything inside the grouping symbol will affect x. It's going to be a horizontal translation, which means the graph would move left or right, depending on what this number is. Now, something very, very, very important about affecting the x, okay? It's always going to be the opposite. So in other words, if you're minusing 2, if you're subtracting 2, you're going to be moving to the right. So x minus 2 moves right. We would say horizontal translation, right 2 units. Now, if the b value was, say, 5, so that would be an if, then statement here, if b equals 5, okay, then we would be dividing all our x's by 5. Okay, then the x values would divide by 5. Whereas up here, when we're moving right 2 units, we would be adding 2 to the x values. Now you're going to see what I mean by this in a little while. So just for now, write this all down. Okay, k value is going to be a vertical translation. Okay, up or down. Now vertical is not opposite. If this was a 2, we would multiply the y values times 2. Okay, if it's plus 3, then we would add 3 to all the y values. So you're going to see what I mean shortly. Okay, so it's a lot of information I'm throwing at you, but we will be practicing these transformations pretty much in every unit for the rest of the year. So let's go ahead and move to an example of this. So let's take a look at this example here that I have started. You may want to pause the video and write this down. So here we start off with the parent function for an absolute value function, absolute value of x. Here's your parent table. So whenever we are going to perform a transformation, we always start with the parent table. Okay, so here I've written down the parent table. Okay, over here what we're going to do is we're going to do the math, the algebra, the operations, and we're going to find our new y coordinate first. So the first thing we want to do is we want to follow order of operations. So we're going to multiply by 3. Remember, the absolute value is your grouping symbol. So anything on the outside affects y. Okay, so we're going to multiply by 3. And then we're going to subtract 4. So let's do the math. 2 times 3, 6 minus 4. 1 times 3, 3 minus 4. 0 times 3, 0 minus 4. 1 times 3, 3 minus 4. 2 times 3, 6 minus 4. So now we have our new y coordinate. I'll just call them new y values. Hopefully I'm still on there. Yep. So remember, we're trying to find the graph for this function by hand. Okay? Now, let's affect the x. So the first thing we're going to do, again, order of operations, we're going to start with the 2. So remember what I said on the previous page, we're not going to multiply by 2, we're going to divide by 2. But a more sophisticated way of saying divide by 2 is to multiply by a half. So we're going to multiply by a half. And then we have a translation of 1 unit to the right. Remember, these are opposite. So if it's times 2, we're dividing by 2. If it's subtract 1, we are adding 1. Okay, let's get our new x values. So negative 2 times a half. Negative 1 plus 1, 0. So we have a new coordinate of 0, 2. So negative 1 times a half plus 1. 0 times a half plus 1. 1 times a half plus 1. 2 times a half plus 1. Okay. So let's write these coordinates down. All right, I got these coordinates written down. These are going to be our new coordinates. So now, if we were to graph this by hand, we would now want to plot these points. So I'm going to go ahead and pause the video just for a moment while I set up a graph. Why don't you do the same thing? Okay, so for this graph, notice that I have started off with my parent. So I plotted my parent equation. So I want you to see how it compares to our new equation. So the next thing I'm going to do is plot these points. So 0, 2. I'm going to use different colors so you can see the difference. 1/2, negative 1. 1, negative 4, 1.5, -1. You see the symmetry going on here? 2, 2. So now we have our new graph. So what we can see right now is that our graph translated 1 unit to the right and 4 units down. So if I start here at my parent, 1 to the right, 1, 2, 3, 4 down. See how the vertex translated to the right 1 and 4 down. And that's right here. This is H and K. H and K will always give you the vertex, at least for quadratics and absolute value. Now the rest of this, why it's so narrow, okay, or you might say so stretched, okay, narrow horizontally, stretched vertically. Well, this 3 is what's causing it to stretch vertically. And this 2, which remember we ended up dividing by 2 or multiplying by half, is what's causing the narrowness, because horizontally it is being compressed. So back up here, this is a vertical stretch. This is a horizontal compression. Okay, these are going to be the opposite. Okay, we'll talk more about that later. But A and B are opposites. A is vertical, B is horizontal. Okay, if it's greater than 1, it's going to stretch it. If it's between 0 and 1, it's going to compress it. Now let's just take a moment and go to Desmos and see if Mr. Kramer did a good job. So let me bring Desmos up on the screen here. Let's take a look. Okay, so here is our parent. Okay, I went ahead and typed in the new one. See, that's our new one. And this matches the graph that we just made. Now I'm going to go ahead and make the points show up. The points that we found. These points right here. Alright, and make sure they match the graph. So here is 0, 2. Here is a half, -1. Here is 1, -4. Here is a 1.5, -1. And then 2, 2. So you can see how the new points that we arrived at creates the new transformed graph. I know this is a lot. I threw a lot at you, but now you have something you can start studying, dig your teeth into, and please start asking questions. See you guys in class.